Okay, in this question we have a 5 kilogram box that's being pulled up a slope at constant speed. The slope is at 25 degrees above the horizontal. The tension in the rope is 38.5 newtons. Use a graphical method to determine the magnitude of the frictional force and the normal reaction force on the box. Okay, start off by drawing a rough free body diagram. We've got weight acting vertically downwards, we've got the tension acting along the rope and parallel to the slope, and then you've got the normal reaction force acting perpendicular to slope, and then friction is acting in the opposite direction to motion, also parallel to the slope. Okay, we're told that it's moving at constant speed and we're asked to use a graphical method. This means we need to understand that because it's in equilibrium, that the forces, if you add them tip to tail, should make a closed shape. So we're going to use a scale diagram and make a closed shape by adding these forces. Okay, so the mass of the box is 5 kilograms, so its weight, I just had to multiply by 9.81, so you get 49.05. So I'm going to use a scale of 50 newtons equals 10 centimeters. This should allow me to use most of the A4 piece of paper I have. Okay, that means I'm using 5 newtons for 1 centimeter. So that using that scale, I have to draw a vertical arrow downwards because weight is acting vertically downwards of 9.81 centimeters long. Okay, so I draw that on. Okay, the next force to draw on I'll do is the tension. The tension is 38.5 newtons, so that means using the scale I have to use 7.7 centimeters on my diagram here. And I know the tension is acting parallel to slope which is 25 degrees above the horizontal. So I'm going to measure it from the vertical, so that means from the vertical is going to be 90 minus 25 degrees. So it's 65 degrees from the vertical. So using my protractor I'm going to mark that, okay, using cross-eyed this, and then 65 degrees there, and then use my ruler to measure out 7.7 centimeters and then draw that on. Okay, right, so next step is to draw on either the normal reaction force or the friction. Now I don't know how large the normal reaction force is, but what I do know is that 90 degrees to the tension, because the normal reaction force is going to be perpendicular slope. So I'm going to use my protractor again and draw a dotted line like this, 90 degrees. Okay, so and the frictional force is also going to be parallel to this. Okay, so it's going to be parallel to the tension, so it means perpendicular to the normal reaction force. So all I know is it's somewhere along perpendicular line here to the dotted line I just drew. So I'm going to move it up the page, okay, and then until it closes this shape like this. Okay, so it's somewhere over here. So I'm going to draw an arrow there. Okay, the frictional force is going to be down the slope, and then now I can also draw on the normal reaction force, because I know it's going to be acting along that direction there. So now I've got all my forces. Okay, now we can use a ruler to measure the length of the frictional force here, which is 3.6, and then using the scale factor we can convert it into newtons. So times that by 5, you get 18 newtons for the frictional force down the slope. And then do the same for the normal reaction force. So that's 8.9 centimeters, so times that by 5, you get 4.45 newtons for the frictional force.